Hello everyone and welcome to today's webinar hosted by Esri UK and 1Spatial on achieving next generation utility network management. Before I introduce our speakers for today, I'd like to go over a few housekeeping items. Today's webinar is being recorded and we'll be able to share a link with you after the event is complete via email. We also invite your comments and questions for today's presenters by typing your questions into the control panel. We will collect these and address them during the Q&A session at the end of today's presentation. And if we don't have time to get to your question, please don't worry, we will answer it after the event is complete. We also have a survey at the end of the webinar, so please tell us how we did. It should take no longer than 2 minutes and we really appreciate the feedback. So for our speakers today, we have myself, Elleni Rogers, and I'm the technical pre-sales lead for the utilities sector. And I also have with me my colleague, Charles Kennelly, CTO of Esri UK. From 1Spatial, we have CTO Seb Lessware and Phil Francis, who is the solution architect and utility network lead for 1Spatial. So before we jump in to show you ArcGIS Utility Network, I want to spend a little bit of time here just talking about some of the industry challenges that have contributed to the conception and development of this technology. Utilities in the UK and at a global scale are under an immense amount of pressure to move towards more modern, innovative solutions to combat some of the shared industry challenges that we see here. The move to net zero and towards more sustainable networks in the face of climate change and an increase in extreme weather events have seen utilities use data and digitalization as a tool to become more responsive and provide intelligence for where to invest in the future energy system. Coupled with the challenge of increasing customer demand and population growth, and not to mention aging infrastructure, utilities are simultaneously being asked by regulators to get smarter, faster, and more responsive. And so responding to these challenges, the UK's leading energy and water organisations have demonstrated the significant role that digital information and technology can play in becoming more responsive utilities. And this really comes to the forefront through some of those digitalization strategies that have been released in recent years. And overall, there is a clear and common message that emerges from all of these strategies. Firstly, there must be a digitalization process to move away from outdated workflows where data may take days, weeks, or even months to get into the hands of those who really need it to make decisions. We will see shortly in today's session why ArcGIS Utility Network can provide that digitalization framework that then enables a foundation for utilities to integrate new technologies like Internet of Things, SCADA, real-time and big data analytics in the cloud. Data quality also plays a huge role for UK utilities, meaning they can respond quicker and more reliably with accurate data that can be trusted. High quality data is also crucial for the adoption of technologies such as augmented reality to see underground assets, or using machine learning and hydraulic modeling techniques to predict the future state of the network. ArcGIS Utility Network has been developed to enable utilities to maintain data that is of high quality, and we'll see that in some demonstrations later today. And finally, utilities are being required to collaborate their data to rapidly identify where there is opportunity to work together to invest in sustainable solutions that benefit both the customer and the environment. And we'll see how ArcGIS Utility Network fits into the wider ArcGIS system that can then be used to share that most up-to-date authoritative network information with stakeholders or even with the public. But how exactly does ArcGIS Utility Network fit into these strategies and provide that digital framework for next generation utility network management? I'm going to hand over to Charles, who's going to expand on some of the carefully designed technological aspects of ArcGIS Utility Network. Charles, over to you.
Thank you, Elleni, and good morning, everybody. So I just want to spend a few minutes talking through some of the technology and thinking behind utility network. And I've just grouped into a few areas, and we'll just talk through those. So first of all, the technology is provided as a web service. It's everything, all the functionality available in utility network is available through a simple REST endpoint. What that means is it can be used from anywhere that can connect to that service. That means the field, it means in the office, it means in web-based devices, it means on mobile-based devices. Traditionally, a lot of asset management work and design work and data editing has been done at a desktop. It's been bound to the desktop with a GIS expert or a technical geek basically sitting there translating what is being seen in the field or what is coming from sensors into your asset register. And that introduces a lag between observation of the need for change and the implementation of that change. The web service-based interface means that we can deliver the full utility network capability to a mobile device, and the person using that device has the same, in theory, the same access to all of the techniques and approaches that somebody sat at a desktop can do. Essentially, the field is no longer a compromise. It's no longer a dumbed down version of the in-office type view, and that opens up lots and lots of possibility. The other thing we've done is it's a very flexible model. The utility network can be used to represent gas networks, electrical networks, telco networks, combined networks, and water networks, and networks that we haven't even imagined yet. It can be configured to represent these different types of networks. And it also is flexible in that if the data that you have today that you would migrate into it is at a certain level of fidelity, it maps the network out in a certain way, and then you want to increase that fidelity over time to be able to do better modeling and more realistic modeling, it can cope with that transition. Another aspect is it's scalable. We designed this to work at the scale of the Chinese electrical grid. We know that as more sources of energy come onto the system and more complexity of delivery happens, and the impact of renewables and electric cars and multiple demands on energy and gas, on water, the networks are becoming more complex in themselves. We can manage that, and we can scale out as those networks grow in volume and complexity. Another important point is that it is rule-based. When you connect to the network, it provides you the rules that you have defined for that network. So you set a set of rules that this type of equipment can only connect to this type of equipment. These two pipes, these two cables can only connect with this thing in between them. And those rules you can check against, and you can validate them at the point at which you capture data. So that means that the data you capture in the field, if that's where you're capturing it, can be correct at the point of capture, and therefore always ready for analysis, which is a really important point. There's no lag between the acquisition of data and the analytics against that data, and that opens up a huge amount of opportunity. And lastly, I want to talk about fidelity. So it is a high fidelity network. What that means is it can represent the equipment that you manage. Quite often in the past, the asset view, the GIS view of a network, showed you where the macro scale equipment was. So you represented a gas governor or a complex electrical substation as a point, and that you then did complicated analysis against to understand how things flowed through it. Now we can represent right down to the smallest components of that network, and they can be spatial things that you map out, or they can simply be connectivity. You say this type of equipment connects to this piece of equipment in this way. That means that we can represent the networks at a level of detail that allows proper digital twin type analysis. You can look at an electrical network and model flow of electricity and demand at a resolution which will hopefully allow you to manage the network much more successfully and model future growth. You can do the same with fluid analytics and so on. In the past, we've seen people extract data from the asset system, add to that data, then do analysis against it to get hydraulic modeling or load modeling, and then bring the results back and look at those results, but they actually don't represent the assets you have in the ground. They represent something that's been constructed just for the purposes of analysis. We can now represent your network at the level of detail that it runs at. And once again, this opens up a lot of possibilities for bringing the worlds of operational management together with the asset management, and those come in the same system. So a combination of those things we think is transformative. Web service-based, flexible, scalable, rules-based, so your data is correct, and able to represent your network at the complexity they actually are. That's why we think utility network is transformational, and we're very proud and excited of it to see what you're going to do with it. So thank you very much, and back to you, Elleni.
Brilliant, thank you, Charles. And so to give you an idea of some of those capabilities of ArcGIS Utility Network and what this means for you as a utility, I'm going to jump straight into a few demo scenarios. And I'm going to focus on a water network and an electrical network for today's session. And I'm going to run these demos in the context of 3 typical users that we would see in a utility. I'm going to consider how ArcGIS Utility Network can meet each user's needs for accessing, maintaining data quality, and then analyzing data to support critical decision making. And let's start with the mapper. The mapper must be able to locate and accurately update the network, especially in a scenario where the utility may need to analyze this data or perform a trace along the network to make a critical decision. The mapper is really the starting point for maintaining that data quality and maintaining a network that meets the modeling and connectivity rules for their utility. So in this example, the mapper needs to extend a water main into a new residential area and is using Utility Network through a web application to complete their edits. I'm going to find the starting asset I'm interested in using the assets ID. And as part of my task, I need to complete the edits starting from this end water main to ensure it's connected to the rest of the network. For the residential area, I need to extend this water main along Sigmund Road so that new customer connections can be made. The first thing I need is a T at the end of this water main. And to do this, I can simply select that water main and go to my network properties that then give me instant access to the rules for my network, which then guide me on what assets can be connected to each other. This ensures that as an editor, I have confidence that I'm getting those edits right first time. I can find the T-fitting that I need and start editing the network. You might notice that the map instantly highlights the valid asset that I can connect to. And as I start to apply my edits to the map, the T is snapped to the end of the water main. Utility Network is connecting those assets together for me and ensuring that my organization can accurately model the direction of flow. I now need to search for valid assets that can connect to that T-fitting, in this case, the distribution main that I need to extend down Sigmund Road. I'll follow the same editing method as before, and this time the T is highlighted on the map as the valid connecting asset. I can now edit the water main, extending the network into the new residential area. To finish my editing task and ensure that the network can be used for accurate analysis by other users, I need an end cap at the end of this newly created water main. I can again use the snapping functionality to ensure that network connectivity. The utility network applies this smart editing instantly, and a really great way to demonstrate this connectivity that's already been applied to the network is by using the network reshape tool. So here, if I've noticed I've made a mistake, I can simply change the location of that end cap and all the other assets, including the water main I just created, remain connected. And this is because the utility network understands how those assets connect and how it connects to enable that flow of water. So let's consider how an engineer might use utility network. For this user, the editing that was just performed by the mapper is really integral to quickly locate assets that need inspecting or maintaining, but also to be able to perform tracing analysis workflows. The engineer can access the latest view of the water utilities network data out in the field, and if there's a leak or an incident, understand how to isolate the network. So engineers out in the field are often required to perform inspections in order to maintain network resilience. And in this example, the engineer needs to locate a water meter inside a meter station that supplies a block of flats. Now, traditionally, this meter station asset would be displayed as a single point on a map, but with utility network, the engineer is able to turn on containment to see inside the meter station and find the water meter that they're interested in. As the engineer, I need to inspect this particular water meter asset, but I also need to know how this meter is then connected to the rest of the network so I can carry out a full assessment. By using my network graph tools, I'm able to view the connecting assets. By expanding each asset's connection, I can follow the same path of how the water would flow coming from the distribution main. As I hover over the meter and the assets connected to it, these features are also highlighted for me on the map. This gives me confidence that I understand how this part of the network operates, particularly if I'm new to the utility and don't have prior knowledge of the area. Now let's see Utility Network Editor in action. As the engineer, I have spotted a leak on a water main whilst out in the field, and I want to know which valves need to be switched off in order to isolate the leak. So I've already created a starting point for the trace, having snapped it to that water main. And I have many different configurations for the tracing analysis, but for this scenario, I need an isolation trace. Once I've hit run, the controllable valves that need to be operated to isolate that leak are highlighted for me on the map, but I can also access a full list of the assets through a configurable report. This means I can act quickly and let the rest of the utility know of the potential impact to customers. So we've seen a number of ways that we can start to use the powerful editing and tracing tools in Utility Network. But there's also other ways that Utility Network lets us understand that connectivity through diagrams or schematic views. So for an engineer, we're now looking at an electrical substation that we've traced up from a service connection on an electrical network. I can open the network diagrams view, and this lets me generate a new diagram, but it also knows that within that map extent that I'm currently in, there's an existing diagram. So I can open that now and have a look. So it's retrieved that diagram, and I can start to zoom in and pan around and understand that diagram representation of the network rather than the map view. And that might be very important for an engineer who needs to understand the connectivity within the substation. I can also use selection tools to select a part or an asset of that particular schematic or diagram. And as I select that, that asset is also highlighted for me on the map. Equally, if I highlight or select an asset on the map, this asset is also highlighted for me in that schematic view. So for our final user story of Utility Network, we're going to focus on customer services. And customer services must be able to collaborate with those engineers on the ground to understand the impact of a leak or a fault and who may be temporarily off supply whilst the issue is resolved. As a member of the team, I can use Utility Network to generate a quick report and find out which of my customers need to be contacted in order to maintain a good level of customer service. So as a customer services manager, I've received the location of the leak from the engineer out in the field as shown on my map. In order to assess the impact on customers whilst the engineer isolates the leak, I can again use the tracing analysis tools. This time, I'm going to choose the customer isolation as the trace type, which has been configured specially for my team. Once I'm happy that I've selected the correct trace type, I can hit run, and Utility Network performs the trace analysis to understand which customers are connected to this section of the network. The customer connections that are impacted are highlighted for me on my map, but they are also available again in the trace report, which returns the list of customers who have been impacted. This report could include customer account details on whether they're commercial or residential services, but I can also export that report to a CSV file, or it could be an external system that you're integrating with utility network, such as a CRM. And so finally, what does this mean for collaborating utility network data with a wider range of users across your utility and potentially beyond? Well, because the ArcGIS utility network is a native part of the ArcGIS system, you can rapidly source that high quality network information through apps like dashboards. If that data changes in another part of the system, dashboards and apps like these update dynamically, so less time is spent manually bringing disparate data sources together and creating reports, perhaps for regulators. You might also use the wider ArcGIS system to bring other data sources like weather feeds or real-time traffic information that overlays your network and used to understand how external factors might be influencing your network. You can then share these maps and apps internally with stakeholders or even to the public. It's completely within your control of how you share that data and who can gain access to it. And so what have we just seen? Well, firstly, we've been able to visualize a real-time model of our network. If an engineer is closing a valve and setting that status to closed, everyone is able to see that information, but then they're also able to use it in analytical tracing workflows. This helps us to improve incident response and make it a lot more rapid to improve that business continuity. It also enables us to coordinate with stakeholders much more effectively and enable them to gain the latest view of the network. This means we can enhance that coordination further and streamline those business processes, and it might also lead to an improved customer service. So you may now be wondering, well, how can I make the successful transition to utility network and make this a reality for my utility? So I'm actually going to hand over to Phil from 1Spatial, who's going to take you through the typical deployment patterns and considerations for deploying your next generation utility network management solution. Phil, over to you.
Hi, good morning. Thanks, Charlie and Elleni. I hope you can now see what a step change the utility network is for utilities, and that it's a real opportunity to get your GIS and your network data to meet the future challenges the utility faces. But it is important to recognise it's more than just an upgrade to your Esri GIS software. So in the next few slides, we want to paint a picture for how you can get there, the things we need to think about and plan to ensure a smooth and efficient migration to utility network. And there are steps you can be taking right now. So on the screen is a high-level series of steps to get to utility network. And really, it all starts with gathering information. How is your current model configured? What connectivity rules are defined? If you're currently running ArcFM on top of an Esri geometric network, what auto updaters are configured? Documenting any existing integrations to GIS, such as your asset management system, and collating business process documents. This may feel like a lot of legwork for something you're going to be replacing, but spending time gathering this information will make sure you fully understand how your current network is modeled and make it so much easier moving forward. And if you're thinking about using an implementation partner, it acts as a really useful knowledge transfer mechanism and will drive out better estimates and better efficiencies. Next, we move on to a data quality assessment, and this is really to get a view and baseline of your current data quality inside your GIS. What existing data quality issues do you have? Getting a proper baseline of your data quality allows you to prioritize what needs to be done and start making informed decisions on how much data needs to be cleansed and fixed, and then you can actually get on and start this activity. And there are lots of data preparation and cleanse activities you can be doing immediately, and we'll focus on some of these later. The more of this cleanse and prep you can do up front, the smoother and easier your transition will be. And then we move on to data modeling and schema configuration. And this is actually the work to define and configure the utility network, its schema and its rules for your organization. And as we'll see, there are a number of pre-configured models which can get you started, but you'll undoubtedly need to spend a bit of time working through options for how you want to model your network. And it needs to be a pragmatic process between your current data, the demands of utility network, and ultimately where you want to take your GIS in the future. Once we have this, we can move on to data migration. And this is really the process of mapping our source data through into our target model. And this is primarily going to be driven from your existing GIS, but it's also worth noting that there may be other non-GIS data sets here, such as asset management data again, which we're also going to use to drive the creation of a richer, better quality data model for GIS. And as we start to migrate data into our model, we then in parallel can use this data to configure our GIS editing workflows and reconfigure or build new interfaces. With the utility network and a new data model will come new business processes, new interfaces, and new applications. And finally, we're able to start testing and transitioning all of this into our business. And depending on our transition approach, we may want an element of dual running and synchronization between the old model and the new model for a period of time. So underlying the utility network is a new information model. And on the face of it, the model is quite small. All of our existing feature classes are actually collapsed down into a handful of feature layers. And a utility network is comprised of two types of networks, a structure network and a domain network. Structural components are managed assets, but aren't really involved in the flow of the utility commodity directly. And a classic example here are poles and pylons. So they support the cables and the fuses, but they don't carry the electricity themselves. And every utility will have a single structure network. Even if there are multiple domains, so for example, water and wastewater, you'll have one single structural network. And actually, that's just 3 feature layers in utility network. And then you have domain networks, which are the things in the network which actually carry or control the flow of the commodity. And each commodity of a utility is represented within a single domain network. So a utility which operates in more than one domain will have multiple domain networks. And again, this is modeled as just 5 feature layers or classes. So as we've seen, the feature layer of the models are actually quite prescriptive. But below each of these feature layers are the concept of asset groups and asset types. Asset groups model the different things in the feature class. So in devices, we might have groups for switches, valve, transformers, and pumps. And asset types allow us to then classify the items within that group. So for example, different types of valves. But both asset groups and asset types are entirely configurable and allow us to model the network flexibly in a way which best suits the organization. And the network rules we build to ensure our network integrity is maintained and defined down to this, are then defined down to this asset group and asset type level. Now, there are some pre-configured data models available where these decisions about asset groups and asset types have already been made for you. So Esri, through their solutions group, offer a number of industry foundation data models for electric, water, stormwater, gas, sewer, and telecoms. And these offer the basic components required by a utility network, but they are only a start point, and some divergence is expected away from these to best meet your organization. Secondly, we're seeing a number of examples of regionalized, community-based consensus data models, where a number of utility organizations, and in this example here, it's a number of Scandinavian electric companies, have collaborated together to define a standardized approach for how they're going to model their networks. And finally, we're seeing a number of business partner models. And these are typically support partner tooling and functionality, which has been built on top of the utility network and often have predefined integration fields. So one of the key benefits, as we've seen with utility network, is its ability to drive analytical and operational insights out of the network. And the way it achieves this is by enforcing integrity through network rules, so defining which assets are allowed to connect to each other and how. It's this functionality at the heart of the utility network that enables the tools, such as the web-based utility network editor demoed by Elleni previously, to maintain this network integrity in our day-to-day operations. However, getting the data to the required level of quality can be a challenge for utilities and is often one of the most time-consuming aspects of utility network migration project. It's worth remembering that the more detail and fidelity we add to the model, then the higher we're setting the bar for data quality, but the greater the benefit and functionality we can then drive out of the utility network. Poor quality and missing data will prevent you being able to model the network how you want to, and can prevent you from being able even to load to the network into a valid state. And in turn, it renders us unable to access and leverage the powerful tracing and analytic functions of the utility network. So, looking a little bit more detail at the data migration process itself, we can actually see that it's a two-stage process. So it goes from the source data to the asset package, and the asset package to the utility network. And the asset package being really a geodatabase that looks and feels like a utility network. And this is useful as it lets us model the utility network and pre-validate all of our data earlier in the process and provides that bit more flexibility. We don't really want to be all the way over into utility network before we really get a feel for how our network doesn't conform to our defined rules, and it generates these things called dirty areas, which we'll learn a little bit more about in a minute. Having the intermediate asset package allows us to decouple the transformation component of the migration and allows for more rapid iteration of utility network configuration and build, and allows us to pre-apply and test our network integrity rules. So as you can see, there are multiple points in this process at which we can apply quality control. And the objective of a smoother and more efficient migration is to try and pull as much of that QA and cleanse work over to the left. So what tools do we have at our disposal to assist with some of this? Well, as you'd expect, Esri have several tools and solutions to assist with the migration. And as we've mentioned, they have the Utility Network Foundation data models. But in addition, there are also things like ArcGIS Pro Data Reviewer extension, which allow you to visually step through data and correct it. And there are also the utility network package tools. So these are a set of Python tools which help you configure and build utility networks and asset packages. Esri and Safe Software have collaborated and created a series of foundation workbenches. And again, these are based on those initial foundation domain models, which are again driven by configurable source and target spreadsheets. And these actually help you do that migration from the source model to your target data model. And there's actually around about 10 hours or so of free online training and resources out there which can help you get to grips with FME, get to grip with the workbenches, and help you undertake that UN transformation. But again, these are very much intended as a start point from which you can then build off and iterate from. And then finally, there's tools such as 1Spatial's 1Integrate, which offer a sort of no-code, rules-based data validation and fix-up. So this can be used to automate your pre-migration data quality assessment and cleanse, but also then both during and after migration, do that cleanse and validation as well. And we offer a number of pre-configured domain-specific rule packs, which help you speed up that rule writing process. And I'm now going to hand over to Seb, who's going to give you a quick demo of how this sort of tooling can be used to assist in getting our data UN ready.
Good morning, thank you, Phil. So here I'm showing a subset of a water network, and this has been loaded into ArcGIS Utility Network, and I'm viewing it in ArcGIS Pro. Now in this case, the existing data we've loaded hasn't been through that process that Phil described, and the data that I've loaded doesn't match all the connectivity rules that we have defined for the network. Now, here you can see the red areas. Those are the dirty areas as defined by the utility network. And they're red because they don't meet the rules. And that means that there's a risk of getting the wrong results if we want to do something like a trace. So the reason we might do a trace is because someone, say, reported a leak like Elleni showed, or a SCADA alarm has been raised indicating that an asset has failed. And then we need to work out the downstream effects. So which assets are affected, which customers are affected, how do we isolate it? But rather than allowing the risk of generating the wrong results, the utility network will warn us if the data is not properly structured. So here it's telling us the data is not properly connected, it's not safe to do a trace. You'll get the wrong results otherwise. So what we need to do is clean up the data to meet these rules to allow us to do this analysis work and allow these traces to work. So when we validate the network, it will tell us which features don't meet the model definition. And each of these are listed. It tells us the feature, it tells us the error codes and the reasons. So one of the reasons that we have is if we've got pipes of different types that meet without a connector in between, because that's what our rules are defined as. And we can go and have a look at that message if we go and look at one of these dirty areas, and we can see the error message defined with that dirty area. So if we look at the attributes, then one of the messages will be the edges are in different subtypes and cannot connect. Okay, so that's telling us why the model isn't met, the connectivity isn't correct. There should be a connector between these two links in the network because there are different types. Now, you're allowed to have links, according to our rules, we're allowed to have links that meet without a connector. So here, for example, this is a valid area. We've got two different sections of our two different pipes in our network, and they're of the same type, and they meet without a connector in between. That's allowed, and that's not been flagged as being a dirty area. But if we go and see, let's have a look at an incorrect scenario. So in this scenario, what we have is we have a service pipe and a distribution pipe. The curved orange pipe is a distribution pipe, and there's no connector where that service pipe meets it. And we can again check this from the error message, giving us the same information. The edges are in different subtypes and cannot connect. Now you can see that's that same error message there. And so in order to correct this, what we need to do is to create a connector. In this case, we're going to create a T object where they meet. Now I've got some, I'm going to define this, create one using some templates. So I'll go and create a T at the right location. And in this case, I'm just going to pick an unknown type because that's something that I've allowed in my network, in my rules, just to quickly show it. And what we'll do is we'll drop one on the correct location where the two pipes connect. And then once we've got that updated in the data, I can then revalidate my network, and we'll see that that dirty area will go away because the network's saying, well, actually, that's now correct. My connectivity is correct. And so that's resolved that issue. Now, the problem is the data I was loaded, I never used to capture all of these T's where things connect. So I have lots of these scenarios in my data. So I need to find a way to automate this process to get the connectivity in my network correct. So now I'm going to switch to 1Integrate. Now 1Integrate is 1Spatial's rules engine, which we use to automatically check the data and also to fix the data using no-code rules. And these rules, we're running a series of rules that are checking the data against the utility network rules. And in this case, first we're checking for missing T's across, this is the entire 150,000 feature data set. The first percentage we have is 41% correct. And then after applying a rule to automatically fix those T's, create them where they're missing, we can see we now get a 96% correct score. That means the 4% represents locations where maybe there's already a T and we didn't create one, but it's of the wrong type. So then we can add new rules to resolve those automatically as well. And we're checking other things like duplicate features, but also the connectivity between various junctions and edges that can be imported from the utility network model definition and then enhanced with any other checks that are needed. But importantly, they can also be applied to the data before we even do the migration to the utility network. And now that all the rules have run, not only do we have statistics and validation reports, but we also have automatic fixes that can be pushed back into the geodatabase. So let's go and have a look at that. Those T's that we automatically created, we can see that wherever we have these service pipes meeting a distribution pipes, we've got the T's created where they meet. And so now we can be confident that the data we're using has the correct connectivity. And so now we can repeat our trace again. So again, this could be because, say, a SCADA alarm has told us that an asset has failed and we need to isolate the network. And so we'll run a trace. This time, when we do the trace, we're going to add a barrier feature. So a barrier feature represents somewhere where the trace is going to end. And this may represent a valve that we're going to close. If we close this valve, which customers are we going to affect? So now we can rerun the trace, and it's going to identify the features that are affected, and it's going to select those, and then it's going to generate the report. And from that report, we can now respond to the incident. We can do our operational behaviors, which will allow us to respond to the incident and contact the affected customers and send the teams out. So this shows us how 1Integrate can make preparing your data for the utility network an automated process, and you can even do it before your data is migrated. And it also shows how once the data is properly connected, then the power of the utility network opens up all sorts of operational benefits. Back to you, Phil.
Thanks, Seb. So As you can see, taking automated approaches to data migration and data cleanse is key to ensuring a smooth migration to utility network. Automation allows us to iteratively and rapidly repeat and rerun migration and allows us to scale the migration both vertically and horizontally. We typically recommend starting with a very small geographical area. We term this the vertical slice. And for initial migration iterations, it's really focusing on obtaining a full asset and feature coverage. Working with smaller data volumes at this stage also helps us to get representative data out early in the process, and that can then be used for application configuration, interface builds, development and testing. But also importantly, it allows us to get development feedback and then further refine the model. Once we're happy with the model, we can then optimize the migration and begin scaling out horizontally to increase the volumes of data being handled until we obtain full coverage, have found all the edge cases, and we begin recording the timings. And then we really move on into dress rehearsals and practice, and ultimately full migration to utility network. As well as the data migration approach, it's also important to consider the transition and rollout strategy for moving your organization onto utility network. And typically, this is a choice between a traditional big bang approach or a progressive trickle migration. So the big bang approach is where we really stop using all the existing systems on one day, migrate the data over, and then we all come in and we start using the new system the next day or the next week. And that requires a high degree of project coordination. There are lots of interdependencies, so applications, integrations, and the data migration itself, and it all needs to come together. And so any of those dependencies which are critical for migration can therefore negatively impact the entire project timeline. Now, it's possibly the most efficient approach if you can do it correctly, but as we all know, projects tend to crescendo and the stress levels can get quite high. So the other approach is taking more of a trickle approach, and that's where the old system and the new system are running concurrently for a period of time. And now that's going to require data edits to be going both to the old and new system, either manually through double keying or with some sort of synchronization mechanism. Now, obviously, that can be in respect to double keying, that can represent some inefficiencies or some additional resourcing considerations. And on the synchronization side, that's great, but obviously that's introducing a potentially quite a complex mechanism, which again might only be transient. But the big advantage is that you are decoupling those hard dependencies between the data migration and applications becoming live, which then lets you iteratively transition individual applications and interfaces to when they're best suited, and they can be scheduled and adjusted, and allows your transition teams or your business change teams and training and all of those that sort of good stuff to then focus on each component incrementally. So overall can minimize the overall risk of transition. And then finally, I just want to go back to some of that upfront data quality work and data cleanse that you can be doing right now. So this is all stuff you could be doing now inside your GIS, and that can range from fairly basic data checks through to more complex spatial and topological checks. So at a basic level, we can profile our existing data. Do we have fields and attributes which are actually null and unused, and maybe we don't need to migrate at all? Do all of our features have unique IDs? Do all of our values in our existing classes and fields conform to the values we expect or our allowed domain values? Or do we have exceptions that we need to think about how we're going to resolve? And at a basic geometry level, we can do those. We can make sure individual features have valid geometries or find lines which are self-intersecting, or perhaps they're just very short lines. We can start doing some of those more complex intergeometry checks. So where do we have coincident devices and junctions in our network? We might have disconnected lines, so pipes which actually aren't touching, or assets which appear to be sitting on top of the network, but then when we zoom in, we see they're slightly off the line. We might even have assets which are currently outside of the service territory, and that might be the result of some existing business process where we place features at 0,0, for example, or somewhere out in the North Sea. Or perhaps it's just coordinates that have been miskeyed or transposed the wrong way around. And then there's finally some of those more connectivity checks we can do. So do all of our medium voltage cables begin at a transformer, and is the transformer of the correct voltage? Do we have different pipe characteristics, and is there a suitable junction and device at that location which allow these pipes to connect? So the sort of example Seb was showing. So there really is a lot of things you can start thinking about now and doing right away as you plan your route towards utility network. And we'd be happy to discuss any of this in more detail. Thanks for listening, and I'll now hand you back over to Elleni to conclude the webinar.
Thank you, Phil and Seb. That was really interesting. So we'll now go ahead into our live Q&A session. And we've had a few questions come in from the audience. One of those questions, I'm actually going to put this towards 1Spatial. So Phil or Seb, please feel free to answer this question. The question is, does my data have to come from an Esri system to carry out the migration?
Yeah, okay, I can take that one. The answer is no, essentially. While we expect in a lot of cases the data will be going from an Esri system into utility network model, it can actually be coming from all sorts of other systems, so it's a similar process that you'd go through to do the data loading.
Brilliant, thank you, Seb. So another question that we've just had come through. Again, I think I'm going to put this to 1Spatial. Can I carry out a quality assessment on a sample set of my data, i.e. if I want to baseline it?
Yeah, I'll take that one. Absolutely. I guess the key is making sure your sample data set is a fair and accurate representation of the entire data set, I guess. So it's if you want to get, the more accurate you can make that sample in terms of a fair representation, the more accurate your baseline would be. So if you pick something that an area that is actually really good because historic reasons, the data quality is really good, then your baseline is going to look really good, but other poor areas are not going to be accounted for. And conversely, if you picked a really bad area, then you're going to get a baseline that that you extrapolate outwards, and it makes it look like everything's really bad. So yes, absolutely, it's just about finding that balance of making sure your sample data is representative.
Brilliant, thank you, Phil. And so there's been a question that's come through that's more around the utility network sort of configuration. So I'm actually going to take this one for myself. The question is, are the tracing capabilities in ArcGIS configurable? And the answer is absolutely yes, they are. You can configure any number of trace types, earlier shown in the demo in today's session, where I was showing the differences of traces between an engineer and a customer services team. These can be configured not just to the types of assets you're trying to find in that trace, but also in terms of the types of assets that you want to report on. So yes, that's absolutely configurable to meet your requirements. And so I'm just going to keep going with some of these questions here. Another question that I want to pitch to 1Spatial. How do we find out how near or far we are from utility network, i.e. what are the first resources to go and have a look at?
Okay, so I mean, I think if I was doing this, I think I would go and have a look at those, the Esri Foundation data models for your domain. And I think I'd spend a bit of time understanding how in those instances they've modeled utility network and how they've done that asset group and asset type sort of classifications, and then start thinking about how near or how far away does that, or how different to is that how you currently sort of see and represent your assets. And as you within that process, you'll understand what the differences are, but because you start to understand those foundation models and how they're constructed, you sort of get a good feeling then of the sort of configurations you can do with utility network, and that ultimately I think will then start to sort of give you that view of where your model might need to go. And so yeah, so there's loads of good resources out there. Certainly the Esri solutions pages, there's countless webinars and all that sort of stuff to go and have a look at, and recorded stuff from which provide a really good insight and a lot of technical details into things. A lot of that safe software training, again, is good background information for how you undertake the migration. And ultimately, I think, you know, anyone that wants to know a bit more, then happily reach out to ourselves or the guys at Esri UK, and we'll more than happy be able to point you in more directions.
Thank you, Phil. Okay, so I'm just looking through some of the additional questions that we've come through. One question is, can you use the schematic view at a larger scale, e.g. at a DMA level? Charles, I don't know if you would like to have a go at answering that one.
You can, in that you build up a sort of a schematic model and then add to it, and you can have a complete representation of the network. Having a completely, the way we like to work is do a trace, get a schematic of that, have an area, do a schematic of that, so that you're looking at the schematic view alongside the asset view, and the two stay very much in step. But yes, you can create a very large scale schematic.
Brilliant, thank you, Charles. Okay, so we do have some more time left, so I'm going to keep rattling through some of these questions. One of the questions, again, I think, Charles, this might be a good one for you. Do sub-networks need to be traced each time, or are assets assigned for use elsewhere, like the dashboard shown?
I don't quite understand the question. They don't need to be traced each time, because you can store the output of the trace. Phil, if you want to drop me an email directly, or sorry, Philip, I'm more than happy to dig into it and get some more detail about the question.
Brilliant, thank you, Charles. Okay, so going through some of the questions here, one, and I'll be happy to answer this one. Can I still have QA or QC procedures before sharing my network data to stakeholders or to the public, i.e. like a local authority? So the answer to this is absolutely yes. The utility network, although provides you the option of having that real-time network configuration, you can still put in security and sort of barriers in place before anyone is able to share that to third parties or the public. So you're able to configure that in the ArcGIS system.
Elleni, if I could just expand on that a little bit. You know, there's a way of working today which is fairly well established, where you do the capture and then you have the QA process around it, and that's a very valid process. I think there's an opportunity with utility network to look again at that process and see, do we need all of it in every case? Obviously, if you're publishing data out or just for your own uses, you need a certain level of QA no matter what. But there are opportunities for capturing some data and making it live directly within your organization, for example. And that could give a lot of savings and efficiencies. So I think you should take this opportunity to revisit the sort of QA workflow, because in the past it was almost imposed because you had to put those checks in place. Now there's flexibility, and I think we're interested in learning what people can do with that.
Yeah, that makes sense, Charles. So trying to make the QA part of your business as usual rather than an afterthought just makes it a lot more effective.
Yeah.
Definitely. Thank you, Seb. Thank you, Charles. That's really useful. Okay, so we do have actually another question on schematics, I think in relation to the DMA schematic question. Can a DMA schematic be outputted to something like PDF for offline use? Charles, I don't know if you wanted to take that question.
I actually don't know. It is essentially, it delivers an image back to the client, and you can save that image. PDF access wouldn't let us follow up on that. I should know it, but I don't. I'm sorry.
No, perfect. I think, yeah, that would be a good one to follow up on. Okay, so we have a few more minutes left, and so I'm going to fit in a couple of last minute questions here. One of those questions is, can we set live statuses on assets like valves when engineers are operating on the network? So the answer to that is absolutely yes. That's one of the key benefits of utility network, is the ability to set a live status on something like a valve, perhaps out in the field when an engineer is operating it, so that a customer service team back in the office are able to see that and perform the right sort of trace analysis for that task.
And Elleni, just expanding slightly on that, there's an opportunity here to give different teams or different roles within the business the ability to edit subsets of your data. So you might have people who are allowed to change the live status, but not the geometry, for example. And that could be another interesting area to explore.
Yeah, definitely, really good point there. The level of control that you can set on these things is really incredible. Okay, so I'll probably say this is going to be our last question for today. So the question is, can I still change the business rules of my network after I've deployed the schema for utility networks? That might actually be a sort of round table discussion. Charles, I don't know whether you wanted to take that on first.
You can, absolutely you can. And the way it works is when a client connects, it reads the rules and then decides what to do with those rules. So you can change it, but obviously you might change it so some of your existing data no longer conforms to your own rules. Then you would validate it and you would see where those dirty areas are, and you'd start tackling it. But absolutely you can make those changes.
Brilliant. Okay. So I'm going to end the Q&A session for today. We have a few minutes left on the call, but I just want to go over to our next slide for call to action. Before I do that, I just want to note that any of those questions that have come through that we haven't been able to answer today, we will get back to you personally through your email address. So please don't worry, we will answer your questions after the webinar. Okay, so we've seen a lot there today on the business benefits of utility network, and then really how you can make the move to migrate your existing network data with incredibly efficient tools that 1Spatial provide. And so we wanted to show some of these resources here that you can see on screen now as a way of you getting more information, or just asking any additional questions that you might not have had a chance to ask today. So from Esri UK, we have Craig Hayes, who is the head of critical national infrastructure. So please feel free to email him directly if you do have any questions or would like to start a conversation around utility network and how it can be brought into your utility. From the 1Spatial side, we also have Jessica Hampton, who is the head of utilities, and a really great contact to ask any questions around the 1Spatial tools that we've seen today and any kind of questions around migration strategies. As part of the additional resources that you'll receive following this email, we are planning to send some learning resources that will be in that follow-up email after today's webinar. So please do take a look. These include tutorials and videos that can help you to understand utility network in a little bit more detail, but also start to understand how it might look for as a reality for your utility. Finally, we also have a feedback form following the webinar today, so please take a look at that form and provide us some feedback. This will help us tailor future webinars to your liking and make sure we don't miss anything that you'd like to see. And then the last thing that I'd like to say before we close the webinar session for today is there is going to be a follow-on webinar, this time with a customer for Northern Gas Networks, as we start to look at some of the lessons learned of utility network and migrating to utility network from their existing data. So that's a really, really great webinar to take a look, understand how has this been or how is this going for a real utility. And so please look out for some of the communication that will be sent out for that. The current preliminary date we have for that is 24th of June, but we should be sending some more information on that shortly. So we've now got about a minute left of the webinar. I'll end today's webinar. Thank you everyone for attending. It's been really great to show you all of what Utility Network can provide and how you can make a start to move to that next generation utility network management. We really thank you for your attendance and hope to see you soon. Thank you.